Hi, in this video, we'll be demonstrating how to set up a sliding gate using the D5 Smart from Centurion. Now, we are moving from a double swing gate to a sliding gate, so you'll see on this installation, see a lot of the old stuff still in place. We are converting this particular gate into a sliding gate there you can see, and that's what the gate will look like at the end. During the course of the video, you'll see some of the old installation still in place. You'll see there are the swing arms. So in your installation, you won't have this. You'll also notice there's a lot of existing infrastructure here. There's wiring and boxes and stuff. That will still be there afterwards. That's not part of the installation. It's not necessary, but we had to work around that. So in this video, we're going to demonstrate how to make the track, how to install the gate motor, all the measurements, how to install the rollers. In this case, the rollers had to be on the inside of the gate because we could not go around the gate because there was an electric fence on top of the gate. We'll show you how to put the rail on. We'll show you how to calibrate the motor. And we'll also show you how to do the wiring. We'll also show you how to do the infrared safety beams, as well as how to use the app to configure the controller. Please note that in some parts of the video, it won't look like your installation. As you can see, look at all those conduits and sprag. That's because there's the existing infrastructure here, so we worked around that. In yours, it won't look like this. You'll see in this installation, we used 2 upright poles. It is definitely not a requirement to use 2 upright poles. We used 2 poles because it had to be offset a bit to the side because as you can see, the double swing motor, the in-ground motor is still in place here, and we had to work around that. I'm now going to show you step by step how we did this installation. In order to put the rail, we need to move the bricks, and then we need to put some cement there, and we're also going to run some cables in this passage. The owner of this property asked us to keep the double swing gate in operation for as long as possible, and that is why we had to work around that. Right, we've now dug our trench for the rail. We've made a hole here for the one pillar, which we're going to put a pillar on this side. This is the motor side. Now, as you can see in this installation, there's a myriad of cables there. And this is going to be a sliding gate, so we've opened the ground where the gate is going to travel towards the wall. Now, in your installation, you won't open as much of the ground as we have. It's just that we've got a lot of cables here. So we're going to put a pillar on that side. We'll put a second pillar here. The motor is going to go about here, and these cables now can be depressed. They'll be inside the concrete. So now it's time to put in the rail. Right, so the next step is to make the gate track. Remember, the gate has to roll along the track. Now you can see what it looks like when it's finished. Now, in our case, we had to join 2 sections. Now, if you have a look over there, there's a join, and then this is the other section. And the reason for this is when purchasing the materials, it comes in 6-meter lengths, but we could not transport it as 6 meters. So we had it at 3 meters and joined it. So the way that I join it is I leave a gap and I allow the round bar to overlap onto the next section, allowing me to get a very straight line from this round bar to that round bar. And also it makes this part here stronger when I weld over here, and then obviously got to weld on this join over here. So there you can see that's where the join is with the angle iron, which needs to be welded, and then there's the overlap, and then there is the round bar from the section that was welded onto this angle iron. So that also means that this section over here, section number 2, the round bar extends a bit over the angle iron, but keeping in mind that you don't need a full 6 meters because the wheels are not going to travel 6-meter lengths. And the reason for that is the wheels are offset, and you'll see when I put the wheels on. Now, in my case, I used the round bar. I like the round bar, but that also determines which wheel you're going to use, because if you're going to use the angle iron, some people use the angle iron and just face it downwards and put that in the cement, and then they'll use a wheel that has that angle iron shape. The round bar must be welded exactly straight on this angle iron, otherwise your gate will do this. So I've now created a little platform here. If you've got clamps, even better, clamp it. Just some tips here. What I do is I tack it or join it in the first place there at the beginning. Then I tack it again after leaving a gap. Then I tack it again after leaving another gap. And the reason being is I like to get the metal fully in position. I don't like to do deep, big welds in one place, because what happens is the metal gets too hot and it deforms, and you don't get a straight line when you want to put it into the ground. You can see the metal has been flipped now, so I'm now welding on the other side, and as you can see, I leave gaps so that it can cool down, and then I can come back and weld between the gaps again. The reason for this is it makes sure that the metal does not warp or deform or overheat. Then you can go back and do nice deep welds because it won't deform the metal much because it's already been welded along the path, so it can't move much. But if you just weld in one go, maybe you do a 10 centimeter weld, all that's going to happen is it's just going to deform along the line of your weld. So this metal is 5 millimeter. I'm using a 3.2 millimeter welding rod. Even though the metal is thick, what happens is because it's so long, it can bend. So always support it along the path. Now it's good practice to just clean the welds, just check that the welds are good. This is a grinding disc and really just there to remove any of the residue, and you can also use this disc to remove any rust. Right, so there you can see the completed track. This is 6 meters, although as I said, for a 4 or a 4.5 meter gate, you don't need a full 6 meter track. We just painted with some primer, especially where the welds are, to stop it from rusting. Right, I've wet the trench. I've made sure there's no loose debris there. Right, now you need to decide where the rail is going to be. If you put it too close to the pillar, the gate isn't going to be able to open. If you put it too far away, you're going to have to put something here because somebody may creep in there. So what I need to do is first look at the thickness of the gate. How thick is the gate going to be? 4. So this gate is going to be 4 centimeters. So if it's 4 centimeters, then if I put that on 2, that means the gate is going to be here. Because this is the center of the gate. The gate's going to go out 2 centimeters that way and 2 centimeters that way because it's a 4 centimeter gate. Right, so that side is now at 5 centimeters and this side is now at 5 centimeters. So now we can put the rail in the line of the fish line. Right, so here we've got the fish line. The fish line is straight and I've worked it out that this is the reference. It's exactly 5 centimeters away from the rail. We've used some rebars to pin it so that the rail doesn't move. You might want to use some wood just to get the exact amounts. And here is at the back. And there's the fish line. Now you can see we've propped up this track along the route. Even though the steel is pretty thick, it does bend a little bit. And also when you pour in the concrete, that also has a weight and can deform that track a little bit. Generally, I use grade 42.5 cement for applications where cars drive over it, so for paving and things like that. Here is the table which I use to determine how much cement to mix, and you can see that there are different categories: home concrete, medium strength, high strength, and so forth, according to your application. I prefer to do a medium or high strength mix for driveways, especially where the passage of the cement is quite small. And it's always a good idea to put some rebar in there to reinforce it. It helps stop cracking. The cement I used was just the normal strength gain. Now this mix looks a little bit on the wet side, but there is good seepage available for the cement. Together with the track, you will see that I've got 2 white conduits. That's for my cabling. So additional conduits have been run there. The depth of the trench which was dug for this track is at least 15 centimeters along the path, and that allows for a really strong platform of concrete. Remember that cars are going to be driving over it and light trucks, so in this case we put a thicker trench. A tip when doing the smoothing is to make it slightly convex by the track, and the reason for that is that you don't want water to sit on the track. you want the water to run off slightly towards the side. So if you look closely, you'll see that on either side of that track, it's actually slightly convex so that water can run off. It also helps with debris and dead plant matter doesn't collect around the track. So when it's got that convex shape, it's much easier for the debris to roll off, especially in the wind. Ideally, you should leave it for 5 days before driving over it, but that is totally impractical. After 3 days, it can be driven over with a light vehicle. If you have to drive over it, use wood on either side of the track. If you're in a very hot climate and this is in direct sun, try to spray it with water periodically. You don't want the curing process to happen too quickly. It's better if it can cure at a stable rate. Right, now it's time to do your alignment. Now in our installation, we're going to put a pillar over here, and then we're going to put the plate that holds the motor into the ground. I've just bent these little flanges here, and now this must be put into the ground. According to this manufacturer, the plate must be 5 centimeters from the fattest part of the gate, and I'll show you that now. But we want to first find out where to put this pole. Now, because this has already got an installation here, we've had to adjust this so that the pole is not bumped by the arm of the double swing gate. Right, so you can see that by putting that pole there, it's not in the way of the arm of the gate. So we can now cement that pole into the ground and use that pole as the reference. Now, in your case, you wouldn't have had to do this. You would have just removed the old stuff and just put the new stuff. You wouldn't have had to work around an existing gate motor. As you can see, these are the double swing gate motors. If this pole is going here, you need to measure 8 centimeters. That is the minimum. So that means that this plate is going to go over here, because there I've got 9 centimeters. I can go to 8. Now, what you need to find out is how fat your gate is, because you need to install this gate plate 5 centimeters away from the fattest part of your gate. So you need to go and measure your gate. Now remember that the gate is sitting half on this side and half on that side. So for me, the fattest part of my gate is actually this wheel. So in my case, it's 38 divided by 2, because this is 38. So 38 divided by 2 is 19, and I count 5 centimeters. So that means that this plate is going to be 5 centimeters away from that point over there. Now you want to get this plate exactly in line with this round bar. If you have a look, you can see that this plate itself has a thickness. So now what I'm going to do is I'm going to now go and get some flat bar and weld a piece of flat bar from there all the way to here, there to here, to keep this suspended and also to keep this in place. So I already know my measurements now. It's 50 plus 23, and then I'll weld the flat bar from here to here, here to here. Right, we've put this here just to demonstrate the principle here. Now, there would be your roller. This is the bottom of your gate, and here is the rail. You might be using the RAS rail, the nylon rail. Just to show you what the RAS rail looks like, this is a nylon rail. Quite a lot easier to work with, and most people opt for this, but because of the video I wanted to show working with the metal one, because the metal one is more difficult in terms of getting it aligned, while the RAS rail allows you to compensate for an uneven rail. We're going to be using the steel one, and what would happen is you would then weld this bracket like that along the path, and you can see that that width from the gate is 30 or 29. So the maximum you can get there is 29 if it's like that. Right, so now you can see that they've said in the manual that from the fattest point of your gate, measure 5. So that is the fattest point of my gate. You can see that pin there. So all I'm doing is I'm going to measure 5. So I've already put this in place. So this is 5 centimeters, 50 mils from there. Now you're going to have to weld these flat bars onto your round bar. That would be going here. Your round bar would be here, and that's where the rollers would be traveling on. So you're going to weld that. So that's why you need to take this measurement. Now, just to check how this is going to work, you can see that that's 5, and if I put the motor here, there is a bit of room for error. It's going to sit literally in the middle of that cog. This is why you've got to leave that 5 centimeter gap between the base plate and the fattest part of your gate. Right, now it's time to run your cables. This is electrical cable. This is twin plus earth. This will be run in the conduit, which is already there. Then here's your comms cable, depending on the color. I've got brown, I've got white. What I like to do is use at least an 8-core comms cable, because at some point you might want to add some more sensors, a keypad, even maybe an alarm sensor. I've got brown here as well, because this installation is here on face brick, and brown goes nicely with the face brick. And then I've just got some ripcord here, and I'll just run this just in case you might need an extra circuit. So I just run this as well. You might want a DC light or something like that. So here's just some ripcord, 1.5 millimeter, which I'll run all together. Try and keep the electrical cable and the comms cable in separate conduits. I'll take this opportunity now to hit in your earth spike. Just be careful of any water lines, so just check there's no pipes there. Right, I'll just put some water here. When you put an earth spark, it's good practice to make it wet. And as you can see, there's a foundation there from the pillar, so I'm also just making it wet so that when you put the new concrete, it will help with the bonding. While it seems easy enough to install that earth electrode into the ground, there's more to earthing than just putting an earth electrode into the ground. And if you do understand how to do earthing, skip this section, but I'm briefly going to cover some of the aspects of earthing as fast as possible. Now, the reason for putting an electrode into the general mass of the earth is that the electrode has the ability to dissipate overcurrent and discharge any faults that may have taken place. Now, the electrode is supposed to provide you with a very low resistance, a low resistive path from the device to the general mass of the earth, the ground. Now, I'm not going to go into the formulas. I'm just going to talk to you about some of the factors that influence that resistance. The first one is the composition of the soil in the immediate neighborhood. Are there a lot of gaps in the soil? Are there different types of soil in the different layers that the electrode is reaching? Things like that. Then it's the temperature of the soil, followed by the moisture content of the soil, the mechanical composition of the soil, the size, the shape, the number, and the spacing of the electrodes. And no, putting more electrodes in does not necessarily improve the earthing if you do not know how to place those electrodes. For example, if you think having 3 electrodes in the ground is better, but you space them too close to each other, you can actually negatively impact your earth resistance. Right, and the last one is the depth of the electrodes. So I'll quickly show you this table here. Now, if you have a look at the different composition of soil, you can see you've got clay, sandy, marsh, sand, and rock. Now, if you hit your earthing electrode into rock, you can see that the resistivity, or the ohms per cubic centimeter, is extremely high when compared to, say, clay, for example. Clay is only 2,000 to 6,000 ohms per cubic centimeter, while, say, sand, dry sand, is much higher. Look, more than 10 times the resistance of clay. And the reason being is that clay is moist. Now, if you have a look at how temperature affects the resistivity, now if you're in a very cold climate country and your climate is below 0 degrees, you can see that the resistivity of your soil is exceptionally higher than, say, a country with a warmer climate with 20 degrees. That is why we do an earthing treatment. Now, what an earthing treatment is, when you're going to put your earth electrode into the ground, you're actually supposed to dig up some of the soil and put a bentonite mix to surround the electrode, because what it does is it absorbs a lot of moisture and keeps it around that earthing electrode, being able to keep that resistivity low. There are salts which you can also use. You don't only have to use bentonite. You can even put in copper filings and things like that to reduce the soil resistivity. Now, if you have a look at this graph here, you can see that before the treatment, it was 140 ohms. But then after the treatment, look at this, right down to 10 ohms by using that soil mix, the correct soil mix. And then you can see that the resistance changes based on seasonal fluctuations, because you can see these are the months, obviously the temperature changes and rainfall and things like that. And then they do an additional treatment. Now, when you put the earthing electrode into the ground, the spacing and the shape and the size of the earthing electrode all impact the earthing resistance. Now, you don't have to use just a vertical driven rod. In some installations, you'll only be able to use a horizontal wire or both. A round vertical plate can be used and a square vertical plate. In terms of how far the rod should reach into the ground, here's another graph. If you have a look here, the depth, this is in feet. So if you see here, it's got like a knee point here, a critical point here, where you can see that at least have the rod 4 feet into the ground. If you feel like you need an additional earthing electrode into the ground, do not put it too close to the one you've just installed. So a rule of thumb would be to install your next rod at least twice the length of each electrode. So if the electrode you put in was 1 meter, then put your next rod 2 meters away. And then ideally, if you really want to take it to the next level, but this is out of the scope of a gate installation, you would have multiple rod installations all tied together by some bus bars. Right, we've got 3 conduits here. The first one is the main, so there's the mains wire that you can see. Leave about 1/2 meter, and there's the comms cables, and maybe you want to put some alarm sensors, mag locks, whatever you want to add. I've got some extra cables there, and also 1/2 meter. There's my earth spike welded onto the plate. Now this is routing up this side, which I'll show you shortly, and I've got some conduit going in that direction, which I'll... Right, so there goes the conduits routed down there, and I've got a DB board. Now we're going to put cement here, but we're not going to close it completely there. Right, so there you can see the conduit, and that conduit is now going under the driveway. Right, so there you can see the 2 conduits, and now we're going to put the pole and the cement. In this case, we're going to put a pole against the pole that's already there. Right, have your concrete mixed and ready to pour. Right, this gate is going to slide along here and it must come to a stop here. We're going to put a pole here. Now there's already a pole on the wall here, and I'm just going to weld a pole next to it. And it's also going to be anchored into the concrete over here. We're going to put concrete. With this pole here, it means the gate is going to go straight into the pole. The pole stops the gate from going beyond this point. Right, now we're putting this pole here. Remember, this mustn't be closer than 8 centimeters, so it's currently at 8. Then from here to the rail, you need to measure the thickest part of your gate plus whatever you're using to hold your gate in place. In our case, we're going to be using a 50mm angle iron, so I've added 50 plus half the thickness of the gate. So in my case, I'm putting this at 10 centimeters from the rail. You can cement these upright poles on the same day as you cemented the track. We just ran out of time on that day, so we split the work. Track on one day, poles on another day. When you're putting in the cement, just be aware of the conduits and the sprag running there. All right, so now you can see that the poles are installed, they're in the cement, and the track is done. Remember, in this installation, we had to make sure that the gate was still usable while we were doing this transition. Now, in your case, you can put the cement in a nice straight line, and then you can do your brickwork. In this case, when we want to do additional brickwork, we'll just cut it with a grinder. Now, in your case, you would have built a brand new gate, but in this case, the video was done on an installation where we were converting a double swing gate into a sliding gate, and the customer specifically wanted us to reuse his old double swing gate. So in your case, you would have built a new gate, so I'm just going to skip ahead till once we've got the gate into one piece. Good practice to measure on the diagonals, corner to corner diagonal, and then corner to corner on the other diagonal, and get the exact same measurement to know that you have a perfect rectangle. Then obviously you also want to measure the width from at the bottom and then the top. Then what I'm going to do is do some superficial welding to frame this gate. I'll then have to determine where to put the wheels. The wheels need to be not right at the end. So you can see it's offset from the end, maybe 50 centimeters or thereabout. The wheels must be able to carry the full weight of the gate. Now, it's going to put more stress on the center of the frame if the wheels are too close to the edges. And that is why you offset the wheels. So you do not need the front and the trailing wheel to be right at the ends of the gate. And now you'll see I'll do the back wheel also offset from the back of the gate. And by offsetting the wheels from the edges, you're actually allowing the frame to be supported better without it wanting to bend slightly in the middle. When choosing your wheels, you'll notice that they come with a weight-bearing capacity. The wheels that I've chosen can carry a weight of 800 kilograms. All steel used in this installation is no less than 2 millimeters, most of it thicker than 2 millimeters. Now I'm just doing superficial welding because I'm going to now put the gate on the track and just check that everything is straight and everything is correct in terms of the frame. What I'm checking for is that the gate can roll along the track and that the wheels are aligned correctly and that the gate is mating or meeting the poles and then the other poles, the double uprights, and that the travel is correct. What I need to do is install a rail or an angle iron going across here. So there's going to be a long angle iron going all across the gate like that. Then you're going to need two rollers, one there and one on that side, so that the gate does not go like this. So that's going to be welded onto the gate, and the rollers are going to align the gate so that the gate can move perpendicular to the ground along the entire travel. So that also means we need an angle iron like that to meet this angle iron, and when the gate is straight, it's going to be like that, and as the gate moves, it's going to travel between the two rollers. Right, so those two rollers go like that, and the angle iron would be there, and those two rollers will be going over the angle iron like that. So now what I need to do is now go and measure and drill these two rollers in here, and I'll show you how to do that. When you're installing your rollers, please note that even though there's a bit of extra thread over there and there, it doesn't mean that these rollers should be much longer. You want the roller as close to the frame or the metal as possible. Right, so you want just enough for the rail to go through the middle. You can also use your welder to make these holes. You'll just put the current on high. Now it's time to weld the angle iron onto the gate, and this is where those two rollers are going to travel on. I tack it on the one side. I constantly use the spirit level to make sure that the angle iron is straight, and then I tack it on the other side, and then you want to make sure that these rollers meet with this rail along the whole path. You don't want that rail to go up and down, and this also talks to whether you manage to get your track in the cement properly. Now there are many methods to align the gate while it travels. Now this gate just has a horizontal angle iron along the top, which is quite common. If you have a look at this gate, the rollers are pressed against the gate itself. This is a nice plan because it's very easy to do this. You make the frame, and the top of the frame is actually the rolling platform. Now in my case, I couldn't do that because the gate had a pattern on the top and it wasn't horizontal on the top, and also there's an electric fence that goes on top of the gate, so I opted for the side rail and the rollers go on either side of that angle iron. Right, so now that the rail is on, you can see I haven't completed the rail. We just have to add another small section to it. It's now time to weld all the sections thoroughly. So at this point, you've got to think in terms of what's the worst that could happen to this gate. While the gate is strong enough to open and close, what happens if a car bumps into it? You can't have this gate just falling to pieces. So it's got to be very strong, a lot of welding. You might even need to put extra steel just to support it in certain places. Remember, this was a double swing gate. I have added a few additional pieces of steel just to reinforce the gate. Right, so now that the gate is welded and it's not going to have any shape change, it's time to decide where you're going to put your rollers. So I've measured it, I've rolled the gate up and down to make sure that those rollers mate with that angle iron along the entire path. Can you see that the face of the roller should meet with the whole face of the angle iron? So you don't want a situation where only a portion of the roller is mating with that angle iron. You can see my whole roller is being pressed up against that angle iron, and now I'm welding that piece that goes across to the gate. And before you weld it, make sure the gate is 100% vertical. So you're always using your spirit level, constantly checking the levels. Now there you can see a view of both rollers. Remember, I'm using 2 rollers, and the reason why is I just wanted to give that extra support because this gate had to be designed while the double swing gate was still in place. I decided to go with a double roller setup. That just gives the gate a little bit more support. It doesn't wobble much because the gate has that electric fence on top, and I cannot go over the gate with steel because the electric fence is too high. Right, when the gate gets to its fully closed position, it should be held in place by 2 pieces of metal. There are many ways of doing this, and this is the way I do it. I use I think this was a 5mm strip of steel, and as you can see, it's flared. So I flared it just in case the gate comes in at a slight wider angle. Therefore, the flaring of that metal will force the gate into position. And there you can see the metal is flared and welded. While the gate is pretty stable, if I try and wobble the gate, it shouldn't go outside of those 2 pieces of metal. And that is why I was hitting it on the floor there just to flare it. There you can see a close-up, and you can see that steel must be thick. Right, now we're just putting on the final piece of angle iron. And the reason being is, just, as I said, we couldn't deliver the 6-meter angle iron. Ideally, if you could have this all in one piece, it's much better, but we have to just weld that on. Now, the gate in the final open position, the maximum opening position, needs to have an end stop. First reason for this end stop is a physical protection. Just in case the motor fails or something happens, the gate must never come out of its rail system. The roller's on the top, so this stops the gate from opening beyond the maximum position. Also, some motors, as you see in this video, the one I'm using, uses that end stop as a calibration technique. End stop must be able to handle that gate opening at full speed, and that end stop should be able to stop it in its place. It also needs to be high enough so that the wheel can never climb over the end stop. To determine the position of the end stop, open the gate to the maximum and then put the end stop a little bit further back, making sure that the track never comes out of the roller. Now, you may have noticed that some of the steel has a bit of rust forming. It's just superficial rust, but it's always a good idea to clean the welds and get that rust off so that you can now do the priming and this painting. Right, so you're going to open your D5 like this. Right, so you want to remove the charger. I'm leaving the earth on, and just make sure it's not connected to anything. You can see everything is unplugged here, and all I'm doing is I'm pressing down and outwards. There we go, and I've removed the charger. The next thing you want to do is remove this. You want to unlock this, and as you unlock it, you will see these locking pins on the side here. There are 2 red locking pins that move. So I'm going to unlock it. Now, if you have a look here, you can see this is open, but if you see that if I lock it, you can see how that is moving as I lock and unlock it. So I'm now going to unlock it and open the door. And now what I can do is put my screwdriver here and just open that like that. You'll see there's 2 black flanges on the sides here, and as you can see, this can come up and remove it. Now you've got access here to mount this. If you want to move this out of the way, all you need to do is unclip at the back. So if I unclip it, you can see that rotates forward like that, allowing me to have access here on the sides. Right, so now all I need to do is put this onto my mounting plate. In the bag, you'll see you get these half nuts, and I'm going to show you what to do with them. Right, you'll see you get a full nut and a half nut. You want to now work with the 3 half nuts. So I'm going to thread the 3 half nuts onto the bracket here. Then you want to put this on top, and you can actually turn this by hand. Right, now what you want to do is you want to measure 12 millimeters from the base plate, the surface here, to the bottom of the half nut. Right, so you've put these three on. Make sure that from the base plate to the bottom is 12 millimeters. It's just the distance from there to the bottom of the half nut. So those three are in place now. Now there's my cable run. Don't worry about this. This is an additional cable which I have here. Yours will look like this. Now mine's a little bit off center, so I'm just bending it with a screwdriver to bring it inwards a bit, and this one as well. Right, if yours is a retrofit installation, you're going to find your cables are a little bit different, and you'll find that there'll be more here. You can route them over here, or there is space on the new D5 for that cable run. You'll see that there's a space there and there, but the best place is there. If you can, try and get them through this space over here. So what I'm going to do is I'm going to thread the wires through there and seat the gearbox now. Right, at the back you'll find there's a flap that can open. So you open it like that and slide it up. That'll make it much easier to thread your cables through here. Here is the cable run section. This now needs to be flipped to face the gate. Okay, what I need to do is cut mine a bit lower because it is knocking on the inside over here. So I just need to give that a bit of a trim. Then I can put this over there. Once you've run your cables in the conduit, it's a good idea to put some silicone in, just in case some water piles up there, stops the water from getting into the conduit. Okay, so now I can put that on like that. And then you can put this cover back on. Right, now what you want to do is you want to push this as close as possible to the gate as you can. Then what you want to do is you want to put this spacer on your cog. Right, now you want to put these nuts on. They just fit over. So these are the height adjusters, allows you to adjust the height from this side. Remember, you have left a 12 millimeter space between the gearbox and the plate. Right, now what you want to do is just make sure it is level. Okay, so on mine, you can see that it's a little bit off. So what I have to do is either reduce that side or lift this side. So on mine, all I need to do is reduce that side. All right, so it's a size 19. Right, now I'm level. I'm just checking in this orientation. Right, I'm level there as well. Right, in our case, we're using the steel rail. There you can see I've placed that on. That provides you with the 2 to 3 millimeter gap. And I've pushed the motor right against the gate as much as possible. Now I'm going to rest that there. And here are these brackets. Right, so there you can see how we're doing it. Now what we do, we're going to weld this one. We're going to start here, and then we hold the spirit level on the rail. As you can see, look how that is deforming. It means it is too tight onto the plastic there. So we need to have it a little bit higher. So I'm going to now weld the first bracket over here. If your motor is moving too much, I just put the nuts on. Right, so I'm doing a final check, just checking that this is all straight. Yes. Yes. Right, you want to check that your rail is straight or vertical. So you want to put your spirit level and just check. As you can see, it is very close there, but it is not squashing this pinion spider teeth. So now what to do is we drive the gate to the middle of this one rail, and then we fix the other side, the suspended side, on the other side there. Right, we've checked that it's level. We've now driven the gate into the middle of this rail, and now we're going to affix this side. Have a quick check at the spider pinion and just make sure that it is not very tight on it. Right, so there you can see the D5 is pushed all the way towards the gate. The rail has been welded here. This is not that easy if your rail is not straight. Now, this was a problem that we had. Even though the rail came from the supplier pre-packaged, we actually saw that the rail had a slight bend to it, and that was making this challenging. Now, all right, I'm just going to summarize how you put this rail on. Now, the manual suggests that you must put the spider pinion here, put the rail here, use a spirit level to get your alignment, tackle weld the first bracket, then move the gate towards you, maybe midway along the rail, And then using the spirit level over here, you would tack your final side. So you would have an attachment point here and at the beginning, making sure it is straight. Now for my 4-meter gate, they didn't actually supply enough of these brackets, so I added some of my own and I added some extras. So you can see that instead of every 30 centimeters, I have extras. I have it almost every 15 centimeters. And the reason being is that in cases like this, especially in Johannesburg, people can be standing on this side of the gate and then they wedge a screwdriver underneath the rail and they lift this rail up. And when you lift the rail up, it bends upwards like that and it comes off the gear. Therefore, you can then slide the gate and therefore you've now broken into the property. So it helps to put some extra brackets. What you can also do is put a piece of flat bar all the way along here, blocking anybody from putting their screwdriver, or you can shield the gate with a piece of sheet metal. Right, then over here I've welded the one rail to the other, and what you can do is you can use a piece of offcut and just clamp it there and clamp it there and then just tack it and then weld it finally. Where did I get this? This is just an offcut. As you can see, I cut a piece off because I didn't need the full 4 meters for this gate that I've installed. Right, they recommend you use this pinion spider as I've shown, and what you do is you put this there and you let the rail rest on the pinion. That allows you to have a 2 millimeter or 2 to 3 millimeter gap between the rail and the gear. Then they recommend keeping this pinion spider and then making sure that at each point the rail is just touching the pinion spider but not pushing very hard onto the gear itself. Now our rail was a little bit bent even though it came from the suppliers brand new, so this became quite challenging. The aim of this exercise is that you want to have a 2 to 3 millimeter gap between the D5's gear and the rail. So as long as you've got that gap, you have successfully installed your rail. Now my D5 is not bolted down yet because you want to see if the rail is pushing too hard on the D5 and then it will wobble. That also shows you that the rail is out of alignment. So what you want to do now is you just want to follow the rail and use your eye and make sure that along the entire path the gear does not exceed that 2 to 3 millimeter. When you are doing this alignment, make sure your rail is free of any stones and debris. Right, now you can fasten this down. So I can remove these nuts here. I just had these nuts here just to stabilize it, although the manual says that you mustn't install the nuts and the washer until you have aligned the rail completely. If your rail is too high or too low, you can use a size 19 and then you can adjust these. You're therefore adjusting the height of the unit from on top. Now because mine is calibrated and it's fine, I'm now going to go ahead and fasten this to the plate. Right, so you can see mine is straight. Alright, the procedure is to put your spring washer in now. You then put your nut. Then on this side you want to put your earth lug over there and then your nut on top. Now you can tighten these. When you're tightening this, make sure the earth lug stays close to the side. So you want it more like that, because it's going to sit in that cable route over there. You can now tighten this. When you tighten this side, make sure you support this lug so that the lug doesn't rotate round. The manual does not specify a torque value. So it does not have to be very tight, just tight enough to compress that spring washer. As you can see, it is now solidly in place. Now just do a final check of your rail. And just make sure the rail is sitting in the middle of the gear. It's fine if it's a little bit off center, but it should not be sitting too much to the side or too much to the other side. It must not slip off that gear. If your override sensor had come out, to reinstall it, you just press down. For example, if you want to take it out, it goes like that. And if you want to put it back in, it slides vertically down. Right, I'm now going to put this cover on. Make sure this is vertical. If this thing has shifted to the side, it will not allow you to put the cover on. So I'm putting the cover on like this. It seats right there, and now I can press it down. You'll see a tab on the left and a tab on the right, which engages. Now I can reseat my charger. You'll see there are 3 clips over here, and they're aligned to 1, 2, and 3. Sits like that, and you press back. Now you can plug in your connector just like that, and this connector over here. Now at the back there's a tab. I'm going to lift it to move that out of the way so I can insert the batteries 1 and 2. You need 2 7 amp hour batteries. The power connections must face the charger. Before installing the battery on the right hand side, you can fasten your earth point over here onto the charger. There you can see the cable run. Then all your other cables can be threaded through there under the battery and coming out the front. Now I can install the right hand side battery. So note the positive and negative is on the top. You can see that the battery is not seating on the cable. All of these cables can move. Now you can connect your battery terminals to the left and right battery. Now with the power off, you can now connect your mains to your charger. Disconnect the terminal and connect your live, neutral and earth to this. Open just 1/2 centimeter here. Do not nick the copper. If you're uncomfortable with working with side cutters, please use wire strippers. Right, the wiring sequence is live, neutral, earth, because it says here live, neutral, earth. The bare copper is the earth. Then the neutral is the black or blue wire. Make sure the screw fastens onto the copper and not just the jacket. Plug this in. If you have excess cable, you can push it down into the bottom over there. Right, now these are my comms cable. I have a lot of them and I'll be wiring it up to here. The next step would be to install your safety beams, possibly a keypad, maybe a courtesy light, a siren, and what you'll need to do is also go and download the app. So here is the app. It's called My Sensors Pro. You'll need to have Bluetooth on your phone. You'll install the app. The app will synchronize to the controller. You'll just have to confirm a few things and agree to some conditions. Thereafter, you should see this layout. In this layout, you can see you can have a look at your controller, your batteries, your power supply. It's telling you the status of them, saying okay. It's giving you the I/O status, basically telling you what is the status of each one of these input output terminals. These are dual personality terminals. They can be used as an input or as an output depending on how you set them. Then you can also set up your remotes. If you want to add a remote, it's very straightforward. See, as a remote, for example, you'll say add, and then all you'll have to do is tell it what you want the buttons to do. So there it says button 1. You'll tap on button 1. You can say trigger, and whatever other options you want. And then say, for example, I say next, and then it says waiting for transmitter. So I'll just press the button, and there it's already done. And you can even label it. Then you can go and configure all your remotes to your controller. Right, so I'm done with my remotes. So this remote will now activate as an opening remote, as a trigger remote. I just did the first button. Right, so there you can see my remotes. If I want to remove a remote, it's quite easy. I can just go like that, and I can just say disable. So that remote is disabled. If you want to edit the name, you can. If you want to disable it, you can, and you can even delete it, or you can clone it. Right, to synchronize the gate, you've got to follow some steps. So what you've got to do is you say the 3 buttons, you say settings, and then you're going to say setup wizard. You're going to choose that option. Right, then it's going to give you this warning, and it's going to say confirm that the gate has an end stop and that the gate cannot go past the final position. So once you've confirmed them, you say confirm, and then it's going to now tell you that the safety features of the gate are disabled. So if you have your beams installed, whatever else, they will not operate. The gate is going to move slowly to find its limits. Right, so then press the start button and be prepared for the gate to now move. Right, so it's now saying, did it reach an end stop? I'm going to increase the volume here. Now it's looking for the other end stop. Now it just asks you if it reached the end stop, so I'll say yes.
Did the gate reach an end stop?
Right, now it's asking me if it reached an end stop again. So it says, did it reach an end stop? So yes. Right, then you're going to get some graphs showing you its peak current and speed. Right, it's asking if it's open or closed. Now it's asking if you need a positive close. Right, if you have a look at that, there's the electric fence switch. So that's why I'm going to say positive close, because it just needs to tell the controller that there is going to be some resistance right at the end. And that's what the positive close is. Then it asks, do you need a positive open? In my case, I don't. And now I just say next. Right, now it just gives you the statistics. It says the gate length, the maximum speed achieved, the maximum current, opening and closing, and now I can just say next. Right, now it's going to ask you to configure your IR beams. I'm going to first show you how to install the IR beams, and then I'll show you how to configure them. Right, the next step is to put your safety beams. This is what it looks like when it's finished. There's the receiving safety beam, and this is how it works. When I trigger the gate, and now the gate is closing, you can see that if I block the safety beam, you can see the gate then changes its direction. Just using the i5 infrared safety beams, I have welded a plate here. The height from the floor to the plate is 600 millimeters. They do recommend you use 750, but I prefer it a little bit lower. Now I've drilled a hole there. Right, now to calibrate the other side, all I do is I take some fish line like this. Right, then using a spirit level, I work out where on the opposite side I need to mark off my position. Right, I've drilled a hole and now I can install the sensor. Right, you'll notice that the two boards are a little bit different. The one just has a positive and negative, that is the transmitter, and the receiver has the relay there with the normally open, normally closed contacts. So you can decide which one you want to be the transmitter and the receiver. In my case, I'm putting the receiver closer to my gate motor. Right, I wire it up as follows. Negative is the black, positive is the red. I've just used the green cable for common, and then I use the normally closed option. So there you can see it's normally closed. My signal wires is actually the blue and the green. I've put the green to common, so it actually just means that when the blue is open circuited, the D5 will register an obstruction in the way of the PIR. Right, when you fit your screw, there's a little rubber washer to stop any moisture from getting inside. Now in my case, I'm using a nut and bolt because I've got this steel plate here. Now on this side, this is the transmitter, so I only need the positive and the negative. Right, to reseat it, you put it at the bottom first, like that, and then you depress the top. Just open the cable space there. Top first, seat it, and then feed the wire through the hole that you've just made. And then the screw cover like that. Right, now I have my 4 wires here. Remember, they were red, blue, black and green. So there they are. So the red is going here to my 25 volt. The black is going here to my common, and the green is going here to my common. So the signal wire I've put here to IO3. That is my safety beam signal wire. You do not have to use IO3, you can use another input. Then on your app, you will just click the 3 dots, you'll go to settings, then you go to IR beams, and then you can actually assign it. As you can see, I've put it there on IO3. If you wanted to, you could change the input, but I'm leaving it there on IO3. Now you need to tell it if it is IRB opening or closing. The most common scenario is closing. There you can see it stops the gate from closing on the car. If you want the gate to stop on opening, if there's something in the way, then you will use IRB opening. There are some other settings which you can play around with. If you're worried about people stealing your motor, you can get custom made brackets to protect your motor. How this works, this particular one, you put this one over like that, and this goes through like that, and just make sure it's unlocked, and then you can lock it. This particular model, the D5 Smart, comes with an alarm function, and how it works is it senses vibration. Maybe I'm trying to steal this. There you heard the alarm. Maybe I'm trying to climb over the gate and I bump it. There you hear the alarm. If you'd like to connect your D5 Smart to your alarm system, please check out my video on this. If you'd like to connect a siren and do other security features on your D5 Smart, I've got a video on that as well. And then lastly, if you do want to connect your keypad for a pedestrian input to your D5 Smart, please check out my playlist. Right, so this is the completed gate, and I'll just demonstrate it in operation. This is in real time. I will trigger it. And I'll close it. Right, this is the view from the road. You can see the gate and the electric fence on top of the gate. And this is in real time.